Hey there, math friends. Today we're taking a look at lesson 8.6. So please make sure that you write that down in your math notebook, lesson 8.6. And we are talking about exponential decay functions today. Whew, this is exciting stuff. Well, let's take a look. Now, a quantity is decreasing exponentially if it decreases, and you know that means it goes down, by the same percent in each unit of time. Now, not by the same amount, by the same percent. That's the difference between this and a linear equation. Now, this is called exponential decay. Some examples of exponential decay would include the half-life of radioactive isotopes, the depreciation of a car's value over time, the decreasing amount of ibuprofen in the body after it's taken, the reduction in intensity of radiation as it passes through material, learning curve retention, city population decline, and the elimination of teams in a tournament. All great examples of exponential decay. Now here's a picture that tells us, a diagram that shows us how, what it looks like in a graph. So this is decay of a radioactive substance. And so the age of the sample in years, as you can see, as the number of years passes, the amount of radiation decreases by quite a bit. Not in a standard linear way. It doesn't go in a straight line. It's in a curve, and that's what exponential decay will produce, is a curve. So here is the exponential decay model. Now it looks very similar to the exponential growth model, with the exception of the fact that it has a minus sign in the middle instead of a plus sign. Okay, so the amount that you have at any given time is equal to the initial amount, C is the initial amount, multiplied by 1 minus R, and 1 minus R is the decay factor. R is the decay rate, and that's going to be a percentage, which would have to be converted into a decimal. And T is the exponent raised to the T power. T is the time period. Okay? So when we're all done, of course, it's y equals, the amount that we have is equal to the initial amount multiplied by 1 minus r, the rate, all raised to the t power. Okay, well, let's try an example. From 2002 through 2017, the purchasing power of $1 decreased by about 3.5% per year. Using 2002 as the base for comparison, what's the purchasing power of $1 in 2017? Oh, well, let's see. All right, so the amount that $1 is worth, the purchasing power is equal to, now the initial amount, well, we'd have to call the initial amount that, $1 would be worth $1. Okay. Then we multiply that times 1 minus, now the 3.5% as a decimal, we'd have to divide that by 100, and that equals 0.035. So 0.035. And let's see, from 2002 to 2017, that's a time span of 15 years. Okay, so then we have y equals, now we do the part that's in parentheses first, so 1 minus 0.035 is, that's 0.965. All right, that's to the 15th power. So we take that, 0.965, and we raise that to the 15th power, and that's quite a decimal, 0.5860163, and so on, right? It's a really long decimal. Okay, now we multiply that times 1. Obviously, we multiply that amount times 1, it's going to be about 0.59. Now, what does that even mean? Well, that means in 15 years, if the value of the dollar goes down 3.5% every year, in 15 years, the dollar will only be worth about 59 cents. 59 cents. All right, let's look at another example. You bought a used car for $18,000. The value of the car will be less each year because of depreciation. Yeah, the value of cars goes down. So the car depreciates or loses value at a rate of 12% per year. So we bought it for $18,000. It goes down by a rate of 12% per year. What is the exponential decay model for this? Well, the car's value, Y, is equal to the initial amount that we paid for it, $18,000, multiplied by 1 minus 12% is 0.12, and that is to, and over time as they power. So there's our decay model. Now let's find the value of that car in 8 years. So $18,000 multiplied by 1 minus 12%, and 8 is our power, to the power of 8. Okay, so 18,000. Now 1 minus 0.12 is 0.88 to the 8th power. Now 0.88 to the 8th power is, all right, that's going to be 0.35964, and so on. A whole lot of stuff after that. Now, then we're going to multiply that times 18,000. So, times 18,000 equals, all right, the value of the car, calculator says 6473.42, and some other stuff after it, but we don't need to worry about that because that's the value, 6473 and change. That's the value of the car after 8 years with 12% depreciation. Kind of makes you wonder about buying cars, doesn't it? Worth $18,000 when you bought it, now it's only worth less than $6,500. All right, let's look at another one. Each year in the month of March, the NCAA basketball tournament is held to determine the national champion. At the start of the tournament, there are 64 teams. After each round, 1/2 of the remaining teams are eliminated, so that's 50%. Write an exponential decay model that shows the number of teams, N, left in the tournament after round T. Oh, all right, and then how many teams are remaining after 4 rounds? Okay, well, so we have the number of teams that are remaining is equal to, what was the initial amount? That's right, 64, multiplied by 1 minus 50% is 0.5, and raised to the t power. Now that's our model. We want to know what it is after 4 rounds. Well, let's see. So n is equal to 64 times the quantity 1 minus 0.5 raised to the 4th power. Okay, we got to do the parentheses first. So n is equal to 64 multiplied by 1 minus 0.5 is 0.5 to the 4th power. So 0.5 raised to the 4th power is 0.0625. Nice short decimal at least. Multiply that times 64. And the calculator says 4. N is equal to 4. So after the 4th round, there are only 4 teams remaining. There you go, exponential decay and the NCAA. All right, well, now that we know how to use that formula, remember the formula? The amount that you have is equal to the initial amount multiplied by 1 minus the rate. And remember, that's got to be a decimal, raised to the power of t for the time in days, weeks, months, hours, whatever. All right, exponential decay. Here is your practice for this assignment. Now, of course, you can pause your video and write down the important information so you can do this, or you can go back to the slide where you found this video and click on the practice work there. All right, folks, have a great day. Don't forget to be awesome. I'll see you next time. Keep on mathing it.